everyone, and welcome back to our YouTube channel. Today we'll be learning on glycolysis. Yeah, very fun topic, glycolysis. We're establishing our series so far that once food is brought in, the first stage of metabolism is digestion and absorption of those food substances. And after everything has happened, they are carried to the liver. From liver, it ends up in the heart, and from the heart, it comes back to the different cells of the body. Now, within these cells of the body, we had established too that within the cells of the body, that's where we have phase 2 and phase 3 of metabolism happening. The second phase is actually within the cytosol, the cytoplasm. And there we have glycolysis occurring to produce little amount of energy. Then the last phase, the end product of glycolysis, which is pyruvate, is now carried into the mitochondria where it is acted upon. And then the cycle we have in the mitochondria is actually called the Krebs cycle or TCA cycle. And then we also have the electron transport chain, all aimed at producing more energy. So for today, we'll enjoy ourselves by learning about glycolysis. Glycolysis, from the name, like the way Latin presents words, glycolysis. Lysis should be breakdown of what? The glyco in this case is glucose. Though the books could mention even glycogen, that is when I break the glycogen to glucose, but ultimately it is the metabolism of glucose to give pyruvate. And then of course glucose is a 6-carbon sugar, whereas pyruvate is actually 3-carbon. So that means for me to move from 6 to 3, they split, ensure that when we split in the middle, I'll now be having 2 of them. So usually, as a way of definition, glycolysis is the oxidation of glucose or the metabolism of glucose. We'll cut that out. The oxidation of glucose or the metabolism of glucose to give pyruvate. Now it's fine and simple as that looks. This guy is 6-carbon, a 6-carbon sugar, and it's giving us 3-carbon. That means for me to have 3-carbon, there must have been 2 of them. And we established there's a split. So glycolysis occurs in the cytosol. That is the cytoplasm, the fluid of the cytoplasm. So within the cytoplasm, glucose that was absorbed, glucose which was of course the end product of glycolysis. Remember I mentioned end products of carbohydrate digestion. Remember I mentioned that even though we should have fructose and galactose, within the liver they are converted back to glucose. So ultimately the only thing the cell receives at the end of the day is glucose. So those some cells that need galactose and fructose will change it back, but of course here we're looking at glucose. Now glucose that is brought into the cell within the cytosol is oxidized to give us pyruvate. But like I said, this oxidation involves splitting of one 6-carbon sugar, which is glucose, to 2 3-carbon sugar, which is pyruvate. So from 1, I'm now having 2, and instead of being 6-carbon, it is now 3 3-carbons. So that's about glycolysis. Remember we said it happens where? It happens within the cytosol. Now, it is important to know that glycolysis can either be aerobic or anaerobic. Aerobic means it is in the presence of oxygen. Anaerobic, anytime we hear an or a before a word, a as a prefix, most times it means no. It means no. So right here, no or absence of oxygen. But of course, we'll go into details of that later. Now let's go on. So glycolysis as a whole happens in stages. Now there are 3 major stages of glycolysis, and then there are 10 steps which fall under these 3 stages. Now the first stage, so the stages of glycolysis are broadly our preparatory stage, number 1. Number 2 is our splitting stage. So right here, in preparatory stage, what am I doing? I am preparing the glucose for whatever I want to do, and glucose has to be activated first. It is actually an investment plan. We observe that in preparatory phase, we're actually losing energy. Now, what is the energy? Remember, the aim of glycolysis is for energy. The aim of taking food is for energy primarily before any other thing. Now, so when I'm done taking my carbohydrate food, oh, I'm doing glycolysis. This should be for energy. But in preparatory phase, energy is being used up. Now, this gives an idea of a businessman choosing to do investments. So you realize when he's taking the investment, when he's buying shares, he's spending his money to buy shares. At that moment, it might look like he's not wise. At the moment when he's probably choosing to save up, when he's probably buying books, when he's probably getting materials or resources to ensure he's improving, it might look like it's a waste of money. But right here, that is the preparatory phase. So right here, these guys are making use of energy. They are losing energy. They are using energy to prepare our glucose for what is to come. And the next phase is our splitting phase. And within the splitting phase, the glucose molecule that has been activated will now be splitted to give us two guys. One is G3P and the other is the HAP. We'll talk about that in details. And then during stage 3, there is oxidation. And this oxidation stage is where you enjoy all you have done. So if I'm using my businessman, right here he invests. So he had been doing business for a while, he sees some profits and he invests. So he looks at a good business he should try to venture into and places his money on it. Now after adding your money into it, now there will be a while when you have to split some things. That's when there's a split. So the business is now doing more than one or whatsoever. We have the split stage. But after a while, maybe some years or thereabouts, there should be a time that investment should start paying back. And that's where we'll have our sedative stage. So now under the preparatory stage, so I'll take them one after the other. We have 3 steps under preparatory stage. So under our preparatory stage, which is stage 1, we have 3 steps. The first step here is conversion of our glucose to glucose 6-phosphate. Now, from men looking at this, glucose to glucose 6-phosphate, the only difference between these two guys here is phosphate. And how is when phosphate is added to a compound, it is called phosphorylation. But addition of phosphate to a compound is worthy of note. Addition of phosphate to a compound is in different forms. It could either be when you are transferring from one other compound to another compound. Whenever it involves transferring of phosphate, the enzymes here are called kinase. Or whenever it does not involve transfer, maybe you are just adding from inorganic, you are picking up a phosphate and adding to a compound, the enzyme is usually called a phosphorylase. Now right here, glucose is converted to glucose 6 and our enzyme here is a kinase. So I think that conveys the message that there is a transfer of phosphates. So phosphate is transferred from ATP to ADP. Remember I said this was an investment period. And energy for the cell is actually in the form of ATP. So I want to produce ATP, which is energy. But before I start investing ATP from the first step. So from first step, ATP is invested to give us ADP. And then the phosphate remember there were 3, they changed to 2. The phosphate here is added here to give us glucose 6. And the enzyme here is called exokinase. That's our enzyme of concern, the exokinase. Now, this enzyme, there are some cofactors, magnesium or manganese, are important for this reaction. It is worthy of note so that this reaction is irreversible. Now, there are some keynotes in the entire glycolytic pathway. 3 reactions are irreversible. Step 1, step 3, and then step 10. Every other single reaction is reversible. So when you look at this, you can clearly see that this is step 1, so it is irreversible. So the footnotes you should add as part of your notes will be that during this conversion, there is transfer of phosphate from ATP to glucose to give glucose 6. And the enzyme for this step, which will be your second point, is exokinase. Now, this enzyme is found in all tissues, all cells, but it is from the name exokinase. I'm not being specific. So I'm talking exo, so it can be anywhere. Or we can have glucokinase, that will be in the liver. And then we can also have other people like galactokinase for galactose, fructokinase for fructose. We'll talk about that when we do their metabolism. But for under glucose, the enzyme here is exokinase. And I said it is non-specific. That means you can ask me other, but it's seen in different tissues. And that's why we're having glucose 6-phosphate. Now, And it's what you have known that phosphate can only be added to the end. So this was a 6 carbon sugar. So it's added to the last carbon, and that's why we have glucose 6. Now step 2 is conversion of glucose 6 phosphate to fructose 6 phosphate. Glucose 6 to fructose 6. Now, what's the difference between glucose and fructose? Of course, that's the only difference we are seeing here. We are seeing a 6 phosphate, 6 phosphates. The only difference between these two is glucose to fructose. Glucose is an aldose, that is an aldehyde, whereas fructose is a ketone, a ketose. Now, so the conversion here is actually there's a change in their functional group. And whenever people are similar, but they are only changed by their functional group, it is a particular type of isomerism we call functional group isomerism, which is a subtype of constitutional isomerism, a subtype of constitutional structural isomerism. So glucose 6 phosphate is changed to fructose 6, and I want you to take note of the fact that it is an isomerization reaction. So I have my glucose 6 changing to fructose 6. Now, what else is important to take note of in this? Now, it is a reversible reaction. A reversible reaction. So reaction is reversible, and the enzyme here, look at the name. This is phosphate. They have both of them are phosphate, both of them are 6 carbon. Phosphate 6 carbon. So we call it phosphohexose isomerase. Phosphohexose isomerase. While this one required a cofactor, nothing is talked about a cofactor. They don't require a cofactor. The enzyme is important. Phosphohexose isomerase. It's an isomerization reaction. It is reversible. Remember, the first step was irreversible. Now I go to my third step, which is step 3, and that involves conversion of fructose 6 phosphate to fructose 1,6 phosphate, 1,6 bi or diphosphate. You observe that use di, it's still the same thing. Now, from fructose 6 to fructose 1,6. Now, when I'm moving from, the only difference between fructose 6 and fructose 1,6 is that there's addition of another phosphate, a process called phosphorylation. And the enzyme this time around is still a kinase. So I'll be starting with a fructose 6 phosphate, and I'll be heading down to a fructose 1,6 diphosphate, and it is irreversible. And of course, the source of phosphate is ATP. They give ADP. You still remember our cofactors for any reaction that involves transfer of phosphate from ATP, magnesium, and manganese. And the enzyme here is called phosphofructokinase 1. Specific phosphofructokinase 1. And this enzyme is our rate limiting enzyme. This enzyme is our rate limiting enzyme. So what are we to know about step 3 under stage 1? Someone that had 1 phosphate now has 2 of them, found at both ends. Remember I said phosphate can only be added to at the ends. Now, when you look at it, how does that happen? It is irreversible. Enzyme phosphofructokinase. I'm adding phosphates. I'm transferring phosphate from an ATP to a particular place, and I call it a kinase because it is transferring phosphate. Now, who am I transferring to? A fructose that has phosphate. So I call it phosphofructokinase 1. We have another enzyme, phosphofructokinase 2. Please take note that this enzyme is a rate limiting enzyme. What does it mean when I say something is a rate limiting enzyme? That means the enzyme here is, or a rate limiting reaction. This is a reaction that once I pass this particular step, then the reaction will get to completion. So once glycolysis can overcome phosphofructokinase, then you are good. Except there's inhibition on the path along any other place. As far as you can overcome this, then you are good. And another thing about rate limiting steps is that they are all usually like the longest step. They take the longest duration. So you realize by the time I overcome step 3, then glycolysis can get to completion. So phosphofructokinase is your guy. So we go to the next stage, which is called the splitting stage. We go to the next stage, which is called the splitting stage. Now here in the splitting stage, fructose 1,6 biphosphate. Of course, I said you can still call it diphosphate, but let me use, that's I'll call this step 4, and this will be under stage 2. So fructose 1,4 diphosphate is converted, so converted to, so this will be conversion of fructose 1,6 diphosphate. Fructose 1,6 please, diphosphate to, or splitting of fructose 1,6 diphosphate to give us glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. So right here in this particular step, I have someone that was 6 carbon being split in the middle to give me glyceraldehyde 3-phosphate. Remember, it's fructose, of course, is a ketone, a ketose. So when it's broken down, it's split in the middle. It's giving me both a ketone and an aldehyde. The aldehyde is called glyceraldehyde 3-phosphate, whereas the dihydroxyacetone phosphate is our ketone. And if you could see clearly, it had 2 phosphate at different ends. So at one end, I had 1 phosphate, at the other end, I had another phosphate. That's why we're having them come out this way. Now, so in a way of presentation, I could put it this way, that fructose 1,6 diphosphate is split into 2. Remember, it's reversible, and this will be G3P. The G3P is glyceraldehyde 3-phosphate, and then our dihydroxyacetone phosphate, DHAP. Now, the enzyme here is called aldolase. Aldolase A. Remember, it is reversible. The enzyme aldolase A, there's a split giving me an aldehyde and a ketone. And it is very important you know that in this step, yes, I understand that you are splitting into equal people, that is, you're having G3P and DHAP, but the body produces not just from glycolytic pathway, but generally the body produces more of DHAP than G3P. So that means if I'm having more of this, and the funny thing is that in the next step, as we'll learn, the person we need in stage 3 is only G3P. So glycolytic pathway gets to stage 2, which is step 4, and they split into 2, G3P and DHAP. And usually the one we have, the percentage that we have in the body is 10:90. So during this their formation, we tend to have less of G3P and more of DHAP. But yet still, what the body needs for the next stage of glycolysis is DHAP. Now, so in the body, it's as if I'm actually doing different things, but then you realize I get to split to form 2. But the person I really need is this one. But yet still I choose to form the other one. You realize that will be useless to the body. So what does the body do? It converts the DHAP into G3P. So your question could pop in, and you could have a question in your mind. Yes, from what you said, they split. Splitting should mean I should have 2 people now. So why am I having 10:90? Yes, it is true that from this you should be having equal people. But the thing is that from other means, the DHAP can also be formed. So dihydroacetone phosphate can be formed from other means, and they accumulate a ratio of 10:90. And then so this DHAP has to be changed to G3P, which is needed in the next stage. So that brings us to step 5, where our DHAP, dihydroacetone phosphate, is converted to give us glyceraldehyde 3-phosphate. And this conversion is reversible. The name of the enzyme is called phosphotriose isomerase. And like the other one, they are both 3 carbons. They have phosphate, so phosphotriose. And then isomerase because this reaction is an isomerization reaction. So I'm changing from a ketone to an aldehyde. Similar thing we did in step 2. So we are changing from a ketone to an aldehyde. So you see clearly why is this important. Like I said, we have more of the DHAP form, not just from glycolytic pathway, but from a pathway in the body, and less of G3P. But the person we need in the next stage is G3P. So the DHAPs in the body have to be converted to give G3P, which we use in our next stage, which we'll be going to, which is the oxidative stage.